All right, good morning. This is a very nice question. It's from Photoelectric Effect and is a fantastic reasoning question, and it's pretty deep in its nature, and it's not a shallow question, you can just read an answer. It is really deep, and I would love to explain you this question. So let's read the question. It's from the Photoelectric Effect, and let's read the question first, okay? So it's a reasoning and assertion one from CBSE sample paper. You can see it from the class 12 physics, CBSE 202223. Assertion is that the photoelectrons produced by a monochromatic light beam incident on a metal surface have a spread in their kinetic energy. What does it mean? It's a very difficult statement to understand, right? It's a deep statement. The reasoning is that the energy of the electrons emitted from the inside is lost in collision with the other atoms in the metal. So first let's understand the meaning of the assertion which is given in the question. So I'll just enlarge it so that you can view the assertion clearly. And then let's talk about the assertion. See, in a photoelectric effect, and now I'm giving you explanation. This is the only channel in the country which is giving you explanation. No channel is giving any explanation. They're just giving solutions. So this is your metallic surface. Okay, this is your metallic surface. The photons come and hit the metallic surface, and then you know what happens, right? If the energy of the photon h nu is greater than the work function of the metal, the electron is ejected. Okay, the electron gets ejected out of the metallic surface. So this is your metallic surface, and the electron is ejected. However, there is a particular concept that the electrons that get emitted, for example, you have 10 electrons that get emitted. Okay, so this is another electron that gets emitted from the metal, and then there is another one, then there is another one, just as hypothetical. Okay, we are not getting it. So you have, for example, 1 2 3 4 5 6 7 8 9 and 10. Okay, these electrons have different energies. Why? Because the photon which comes, okay, with energy h nu, first it has to overcome the work function of the metal, and then the balance energy gets converted into the kinetic energy, right? This is the Einstein's formula, right, which you have to memorize, the photoelectric effect. This is the kinetic energy of the electron. Now, if we talk about the kinetic energy, which is the emphasis point, what happens to kinetic energy? Let's focus our attention to kinetic energy and the electrons that I drew on the other side. So let's see the kinetic energy. So each of this electron, this has a kinetic energy, this has a kinetic energy, this has a kinetic energy. Each of the electron has a kinetic energy, but it is different. Each electron has a kinetic energy which is different. Why? The reason is the electrons which are at the surface of the metal from where the electron is ejected. So I am drawing the surface of the metal. The photons come and strike the ones which are at the surface. Okay, at the surface, they have little resistance from the atoms of the metal compared to the ones which are down below. So if there is a atom which is down below, of the metal, and the photon has to go inside, then the atom will release the electron. So electron will come out definitely from here also. If the photon energy is greater than the work function. The problem is the electrons which are coming from inside have a lot of resistance and collisions happening inside with the other atoms of the metal, and therefore their energy reduces. But if you compare to the electrons which are coming from the topmost layer, that electron has to face no collision. Okay, no collision. If the electron is coming from the surface, they have to face no collision. And therefore, the electrons that are coming out of the surface have the maximum kinetic energy. and therefore this particular equation always has max. Okay, this is how we use this equation. If you have to see this equation, go back and check h nu is equal to w. So remember, each electron which is coming from different depth of the metal loses a lot of energy. The deeper it is, the more difficult it is for that electron to come out, because a lot of electron energy. So, for example, look at this layer. The electron coming out because of the the photon striking it. This electron will face so much resistance in coming out because the atoms of the metal. So these are the atoms of the metal. It will face a lot of collision and therefore lose a lot of energy. So the kinetic energy of the electrons which come out, kinetic energy of the electrons that come out is different, is different. And the kinetic energy at the surface here, at the surface is kinetic energy's maximum. And this is what is known as the effect, the spread. Okay, so if you see the question now, let me take back you to the question, right? So what was the question? That there is a spread in the kinetic energy, right? This is absolutely true. The kinetic energy is not fixed. There is a kinetic energy which is max, and there can be a kinetic energy which is minimum, which means the electron just comes out of the metallic surface and stops. Okay, because it is no energy left to move. It does come out, so it is able to overcome the work function. It comes out and it stops. So the kinetic energy is max, and the kinetic energy can be minimum also. So there is a range in which the kinetic energy moves between the max and the minimum, and this is what is called as a spread. Okay, there is a spread of kinetic energy. It is not a fixed value. It varies from minimum to maximum. Minimum can be zero. The electron comes out and is at rest because it came from deep down inside the metal. It had so many collisions that by the time it came out of the surface, got ejected, the energy got reduced to zero. Now, what is the reason? We have already discussed, because the energy of the electrons emitted is lost in collision with other atoms. How much energy an electron will lose inside before it comes out, it depends on how many collisions it has. So both the reasoning is also correct and the assertion is also correct, right? Therefore, our choice is, the answer is A, because both assertion is correct and R is a correct explanation of A. So the answer to this question is A. I hope you enjoyed this explanation. Not many students are aware of this, especially the photoelectric equation which is there. You know that this energy generally which is written is Ke max. So just for your information, don't forget to subscribe to this channel. This is the only channel in the country which is giving you explanation. No application, no website, no classroom will give you this level of detail sitting at the comfort of your home. So immediately subscribe to this channel. Thank you very much.